Show me around the code a little bit and what will change when we want to go live on our big GPUs that we rent from Lambda Labs. I just want to learn. I want to learn a little bit because we don't even code it ourselves. Some people try to drag me for that. And it's like, he's like, bro doesn't even know what his code says. Of course I don't, dude. Do you? Then you're behind. You're behind, bro. Come on. You're behind. You're not moving fast enough. I mean, the only way I know what my code does is if it's like production level stuff. These little shots like new model, boom, boom. No way. No way. Going too fast. Teach me the code. Write it. Teach it. You know it. I got Sonet. I got GPT. I have them all. It's crazy. And they just keep making the models better and better and better for us. So grateful. Okay, so great question. Let me walk you through the local versus cloud production mode and what changes we may have when we hit those big Lambda Labs GPUs. Code walkthrough local versus Lambda Labs cloud. The magic switch line 9. So on line 9 we just hit false. This one line controls everything. When you flip it to false, here's what transforms. Data scale. Data sample fraction, 3.6 days of data. Sample fraction, data sample fraction, 1.0 equals a full. So we're doing 1 versus 1% of data. So it's like 368 days. Model architecture. So we have the same thing here. It looks like, yeah, data sample fraction. Yeah, okay, that makes sense. Model arc. So on our model arc here, let's see, LSTM. Nah, son, I'm talking about, sorry, RF. I was actually wanting you to walk me through the RF liquidation since this is the new one. I noticed you were telling me about the LSTM one. I already know the LSTM one. I need to know my new random forest one. Yes, thank you. Again, talking about what I'll need to change to move to Lambda Labs. Like I see data sample fraction, obviously that's going to be 100x more once we move to the cloud. So I already found that. But what else are other things? Are there any other things? I mean, that's all I really wanted. I wanted you to walk me through the new code, you know? Dun, dun. Generate for me, please, 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 please. Please, oh, please generate for me a little bit faster now. We need a little bit of speed up in here. I'm not asking for the fastest. I get it, dude. Don't need the fast. I need the most consistent. Who's the most consistent in here? That's me. I'm sorry to say, but that's me. I hope you have consistency too, even if it's 5, 10 minutes a day. Just whatever your goal is, just keep going after it, please. Even just on some bad days, whatever. Do lock in for 5 minutes. Run one lap. Come on, B. Moondev's random forest liquidation predictor walkthrough. Let me walk you through your new random forest model. This is your baseline comparison. No sequence is flattened instead. Uses 3D sequences, training speed. Estimated 2 to 5. Okay, 100 estimators, else it's going to be 500. Max depth 10. If local mode, else 20. Okay, end jobs. Lambda Labs, cloud changes needed. You found the main one, but here are all the changes. So this would be 1% of days instead of 368 days. It's about 3.6 days. Model complexity, scaling, and estimators equals 100. Okay, max depth here. 2x deeper. 2x deeper. Min samples split equals local mode, else 2. Max features equals square root if local mode, else auto. Feature set expansion, core features equals 13 features if local mode, else none. Local 13 times 60 equals 780 features, cloud, okay. The master switch, it's just one switch. I just got one switch. I got a switch. You gotta have a switch on there, dude. You gotta have the switch on there. We can't talk about that here, but you gotta have the switch. Lambda Labs setup here, 368 days of data. Random forest advantages over LSTM. Feature importance rankings. You'll see which liquidation patterns matter most. No overfitting issue. Tree ensembles handle noise much better. Faster training, minutes versus hours. Interpretable. Can see exactly which time lags are important. Expected output differences. Your random forest will show Munda's top 10 feature importance. USD like. Okay. This tells you exactly which minute lags of which liquidation features predict Bitcoin moves best. Single change for cloud deployment. Just like your LSTM, one line change. Nice. Everything else scales automatically. The random forest should give you baseline performance quickly. Then you can compare against your LSTM to see if the neural network's complexity is worth the extra training time. Let's run it, son. 2 models. Who this? 2 models, 1 day. Yes, dude. You've only used the random forest.